All right, so let's go ahead and talk about the Pythagorean theorem. So we may have touched base about this last class, but I wanted to go ahead and reiterate it. So to start off, we want to go ahead and discuss what are the parts of a right triangle, right? So we know what right triangles look like. If I were to go ahead and draw one out, right triangles are our right angle triangles. So here's my right triangle. I'm going to put that little box telling me that it's 90 degrees. Right, if I were to label my triangle, here's A, here's B, here's C, right? Those are my angles, A, B, and C. And then one rule of thumb is when we have a side measurement of we have angle A, across from angle A is going to be side A. So it's going to be little a, right? Same exact thing with angle B, across from it is little b. And same with C, my 90-degree angle across from angle C is going to be little c. Okay, so then there are specific vocabulary when we're talking about right triangles. It says in a right triangle, the sides that form the right angle, so my two sides that form the right angle, these are called your legs. So like here's leg B, here is leg A. Okay, so those are my legs. And then the other one, the side that is opposite to the right angle, so across from my right angle of C is little c, this is called a hypotenuse. So hypotenuse. So this is hypotenuse. I'm just going to abbreviate it as HYP. And again, this is the side that is opposite of my right angle. So that is my little c. Okay. And we can find the length of a missing side of a right triangle by using what is called Pythagorean theorem. So Pythagorean theorem, it says in a right triangle, the square of the length of the hypotenuse. So again, this is my hypotenuse, is equal to the sum. Sum is just adding the squares of the lengths of the legs. Again, this is leg A, leg B. Right, so what it's saying is that I have leg squared plus leg squared is equal to the hypotenuse squared. So if I'm looking at my diagram, my picture, I'm going to have A squared plus B squared is equal to C squared. And this is what we want to go ahead and go by when we're solving problems that deal with Pythagorean theorem. And Pythagorean theorem only happens in a right triangle. So let's go and do examples 1 and 2. Let's find the length of the hypotenuse C. So I'm going to go ahead, I'm actually going to go and split screen my iPad so that I can use my Desmos. Okay, so I'm going to go and copy down this equation. I have A squared plus B squared is equal to C squared. If I'm looking at my triangle, here's my right triangle, or my right angle. So I know that across from it is little c, so this is my hypotenuse. And then I have leg A and leg B. So I'm literally going to go ahead and plug in these guys. I have 20, so I'm going to do 20 squared plus B, which is 21 squared, is equal to C squared. We don't know what C is just yet. We have to go ahead and solve for C, so I'm going to go ahead and put my little line in the middle just to stay organized. Okay, I'm going to type in 20 squared in my calculator. That looks like we have 400 plus, I'm going to go ahead and say, okay, I have 21 squared. That's 441, and I'm going to equal it to my C squared. Right, on my left-hand side, I can go and add 400 plus 441. That gives me a total of 841 is equal to C squared. And whenever we're doing this, right, we have to go ahead and take the square root to get C by itself, right? We learned last class if we have, I don't know, like 3 squared, right, is equal to X. Let's go ahead and say that, no, I don't want to do that. Anyways, whatever. We want to go ahead and make sure that we're finding C, so I have to go ahead, and since it's squared, I could take the square root of both sides. That gives me c. So when I'm plugging into my calculator, I'm going to plug in the square root of 841, and that gives me a value of 29. Okay, so that is the last step, is you have to take the square root of both sides, right? What you do to one side, you have to do the other. So that's why we had to take the square root of 841. Okay, let's go ahead and try example 2. So same exact thing. I'm going to go and say a squared plus b squared is equal to c squared. Right, here's my right angle. Across from it is my little c, so that is my c. And then here's my a. We are trying to find b. Right, so I'm going to plug in 6. So I have 6 squared plus, I don't know what b is, so I'm going to keep it as b, 10 squared. Okay, I'm going to draw my little line. 6 squared. Oops. 6 squared is 36. So I have 36 plus, I don't know what b is yet, so I have to go and keep it as b squared. 100 squared, or 100 times 100. Or sorry, 10 times 10 is 100. And then I can keep going. Okay, I'm going to go and subtract 36 on both sides. I'm left with the b squared is equal to 100 minus 36. Gives me 64. Same exact thing, right? I have b squared. I have to have one b. So I'm going to go ahead and take the square root of both sides. So b is equal to, and in my calculator I'm typing the square root of 64. That gives me a value of 8. Okay. So let's go ahead and do the other examples. So same exact thing, right? My first example, I have my c, or I'm trying to find c, so here's my a and my b. So same exact thing, I have a squared plus b squared is equal to c squared. A is, in this case, 12. So I have 12 squared plus b, which is 5. 5 squared is equal to c squared. I'm going to go ahead and solve for c. If I go to my calculator, I have 12 squared, which is 144, plus 5 squared is 25. That's going to equal to c squared, right? Then I'm going to go and add 144 plus 25. That gives me 169 is equal to c squared. And I know my last and final step is I have to take the square root of both sides. So I'm going to take the square root of 169, and that gives me c is equal to 13. So I found my c. Okay, same exact thing for number 2. I'm going to go ahead and write a squared plus b squared is equal to c squared. Same exact thing. It looks like I have a and b. So my a is 10, so I have 10 squared plus my b, which is also 10, is equal to c squared. I have to go and solve 10 squared, or in other words, 10 times 10 is 100. So I have 100 plus 100 is equal to c squared. 100 plus 100 is 200 is equal to c squared. And same exact thing, I'm going to go ahead and take the square root of both sides. I don't know what the square root of 200 is, so I am going to plug in my calculator. Oh, no way! What happened? Looks like we have a decimal, so let's go ahead and round to the nearest tenths place. So one place after my decimal, I have 14 point, that 4 after the 1, right? The 4 is less than 5, so I just keep it as 14.1. So this one is 14.1. Okay, I want you guys to go ahead and try 3 and 4, same exact process, right? If I were to label it, this is my C, here's my A, we're trying to find B. Again, this is my C, here's my A, we're trying to find B. So go ahead and plug and chug it into the equation and solve for B. All right, so let's go ahead and do number 3. So I have a squared plus b squared is equal to c squared. A is 12, so I have 12 squared plus b squared. I don't know what b is yet, but that's what we're trying to find. C is 13, so I have 13 squared. Draw my line. 12 squared is 144. I don't know what b is, so I'm going to keep the b squared. 13 squared is 169. right? Going to solve for b, so I'm going to go and subtract 144 on both sides. So I have b squared is equal to 169 minus 144. That gives me a value of 25. Same exact thing, I'm trying to find one single b, so I have to take the square root of both sides. So I have b is equal to the square root of 25, which is 5. Right? Number 4, same exact thing. I'm going to go and write out my equation. I have a squared plus b squared is equal to my c squared. A looks like it's 4, so I have 4 squared plus b squared is equal to c squared, which is 5 squared. So if I'm doing this one, I have 4 squared, which is 16, plus b squared is equal to 5 squared, which is 25. And from here, I'm just solving for b. So I'm going to subtract 16 on both sides. B squared is equal to 25 minus 16. What is that, 9? Same exact thing. I have to find one b, so I'm going to take the square root of both sides. So the square root of 9 gives me a value of 3. All right, and that's it for notes today.